Hey, this man needs a Pythagorean theorem stat. I need 10 cc's of logarithms with a derivative. Right away. This man's divided by 0. Hey, welcome. It's Wednesday, August 19th, and I'm the math medic here. 1 second, please. Hold on. Yes, this is the math medic. What? Divided by 0? I'm on my way. All right, let's get through this video. I've got an emergency to attend to. All right, what we're doing today is we're using our unit circle to find the exact value, which means no calculator, of these different trig ratios. All right, so this first question is asking you, what is the sine of 11 pi over 2? So what you've got to figure out is if you wrapped a segment that was 11 pi over 2 units long, where would it end up? And you're going to find where it's going to end up, and you're going to look at what the y-coordinate is at that point. All right, so if we go down to our unit circle here, to count by pi over 2, these slices over here, when I divide a circle into pi over 2 slices, I'm going to have 4 slices. 2 slices on the top, 2 slices on the bottom. I want to count where would I land if I went 11 of these slices. So if I counted here, if I started at the x-axis, that's 1 slice, 2, 3, 4 slices around one time. If I go around again, that's going to be 8 slices, now 3 more. 9, 10, 11. So if I wrap that, it would go around the circle 2 3/4 times, and it would land right there. So on my unit circle, that's the coordinates 0, 1, -1, and I want the y-coordinate. So the y-coordinate of this is -1. Okay, the cosine of 7 pi. Well, cosine is the x-coordinate. All right, if I'm counting by pi units, I'm counting halves. Okay, this top half is 1 pi. So I'm going to count 7 of those. So this would be 1, 2, 3, 4, 5, 6, 7. So I would land over here. That's where I would finish wrapping. And when I look at that, the x-coordinate is -1. So you'll need your unit circles. Okay, I attached them to today's lesson on a Google slide. All right, the tangent of 6 pi. So these are my pi pieces up here. It's half of a circle. Start at the positive x-axis. 1, 2, 3, 4, 5, 6. I would land right there, and it's asking me for the tangent. So tangent is the y over the x, and that lands at the point 1, 0. So that's 0 over 1, which is equal to 0. Okay, 7 pi landed at the point -1, 0. And 11 pi over 2 landed, its endpoints were 0, -1. Okay, well, we already did 11 pi over 2. Now we just got to do the cosecant. So cosecant is the y-coordinate flipped. Well, when we wrap 11 pi over 2, our y-coordinate is -1. So when I take -1 and I flip it, it's still just -1. So the cosecant there is -1. Okay, 7 pi over 2. So now I'm working on this bottom circle, and I'm going to count 7 of those slices, starting at the positive x-axis and going counterclockwise. So that would be 1 slice, 1, 2, 3, 4, 5, 6, 7. So it's going to land, it would wrap, and its endpoint would be at 0, 1, 0, negative 1. And cotangent is x over y. So that would be 0 divided by negative 1, which is 0. Okay, secant of 8 pi. Well, that's halves. So 1 pi, 2 pi, 3, 4, 5, 6, 7, 8. So I'm going to land, my endpoint is going to be 1, 0. Secant is 1 over x. So that's 1 over 1. I'm taking the 1 and flipping it, which just means it's still 1. All right, now the last two, they're negative. So if you have a negative value, all that means is that you're just going clockwise instead of counterclockwise. So negative 3 pi now for the sign means I'm counting clockwise. So this would be negative 1 pi, negative 2 pi, negative 3 pi, and it would land at negative 1, 0. Okay, sine is equal to the y-coordinate, so this is 0. Okay, and then finally, negative pi. Okay, so that's going to add, it's going to be at the same place. So start the positive x-axis, go negative 1 pi. So it's also going to have the same endpoint, negative 1, 0. And secant is 1 over x. So that's 1 over negative 1, which is negative 1. Okay, so as long as you know how to count, you just got to find what are the coordinates that after you're done wrapping the circle, what are the coordinates of the endpoint. Okay, the next part is you're given the angle, and then you're asked to find all 6 ratios. Okay, now it sounds like a lot of work, but really it's not, because all of the endpoints are going to be somewhere on this chart. You just got to find where it is. All right, so if I'm doing 2 pi over 3, so I'm going to count 2 pi over 3. So my pi over 3 pieces are on this top circle here. And I want to count 3 of them. Okay, so this would be 1 pi over 3. I'm sorry, I want to count 2 of them. And this would be 2 pi over 3. So that lands right there at 2 pi over 3. Okay, so to copy these, here's 2 pi over 3. Okay, so I got my y-coordinate of that point, my x-coordinate, my tangent. And so we've already computed these yesterday's lesson, so all we have to do is just read them off the chart. Okay, 5 pi over 6. So this is pi over 6 pieces. There's 6 of them on the top and 6 on the bottom for a total of 12. I want to do 5. 1, 2, 3, 4, 5. My endpoint would be right there. There's 5 pi over 6. And there's my 6 trig values. So you can, on your, when you open up your math or your, let's see if I can show you where I put it. On today's lesson, okay, you have this Google slide. So there's your unit circle on the first page, and then the chart and everything on the second page. So I would suggest like maybe taking a picture, so or have 2 windows open on your computer. All right, 210 degrees. Okay, so 210 is at 7 pi over 6. My endpoints are negative root 3 over 2, negative 1/2. Okay, so there's my solutions. Okay, for 210 degrees. Oh, I think, did I skip 5 pi over 6? It looks like I did. I'll copy both of them down. Okay, so 5 pi over 6. And 7 pi over 6, which is 210. All right, 14 pi over 3. So I'm going to count 14 of these slices and see where I end up. So this is 1, 2, 3, 4, 5, 6. If I go around again, that's 6 more, so that's 12, 13, 14. My endpoint would be at the same as 2 pi over 3. So I can use this entry right here for the 14 pi over 3 because they land at the same place. So this would just be root 3 over 2, negative 1/2. All right, so same here, just different angles. I put some negatives in there. Okay, 13 pi over 6. Well, there is no 13 pi over 6 in our chart here. So we're going to count around the circle, and we're going to find which one of those would 13 pi over 6 land on. All right, so these are my pi over 6 pieces. I got 6 on the top, 6 on the bottom, so that's 12. So if I go around one time, that's 12. 13 pi over 6 is going to land at the same as pi over 6. So I'm going to use that column right there. Okay, negative pi over 6. Okay, so for negative pi over 6, I'm going to count clockwise. Whoops, lost my place here. There we are. Okay, so negative pi over 6 means I go clockwise. and it would land at the same as 11 pi over 6. So there's my 6 trig values. So I just copy those onto my, all right, negative 240. All right, so if I was down here, I'm going to go clockwise 240 degrees. So going all the way around, that's 180. So to get from 180 to 240, I'd have to go 60 more degrees clockwise. All right, so this first section here, all right, from 180 to 150, that's 30 degrees. And then from 150 to 120, that's another 30 degrees. So negative 240 is the same as positive 120. So on my chart, there's my positive 120, or 2 pi over 3. The endpoint is going to be at the same place. So now I can copy in those values. All right, and finally, negative 13 pi over 6. So I'm going to go count clockwise 13 of these slices. So going all the way around are 12 slices. So there's negative 13. So that's the same as 11 pi over 6. They've got the same coordinates of where that wrapping would end, the end point of the wrap. So then we fill those guys in, and that's our 6 trig values. So if you can count using these circles and then find the end point, the coordinates of the end point, then you can find out which one of the columns you're going to use on your chart and fill in your 6 trig values. All right, that's it. I'll see you next time. This is the Mathematic, and remember, kids, don't divide by 0. Take care. See you next time.